So yeah, I will start off with saying morning, even it's just still morning. It's a bit echoey. So yeah, this presentation is about, even though it's labelled OpenEdge Object-Oriented Programming and Unit Testing, it's about the concepts, designs of object-oriented, but how not to break it. And how, as all developers, we do break object-oriented every single time, every second of every working day, unfortunately. So I will start cracking on because I have more slides than I anticipated because I thought it was a 60-minute presentation, so I want to try and go through as quickly as possible. So if I do speak too quickly, just raise a hand, say slow down, because I am a native English person and I can speak very quickly, unfortunately. Right, so that's not working. So if I go back one, that's some basic information about myself. Been developing with OpenEdge for over 20 years. Started off in C#, C++, assembly, if people still remember that language. So yeah, I've diverged into many different technologies, and like I said, the last 20 years plus, been stuck in OpenEdge. But I don't mean stuck as in bad terms. I think you've all seen slides about Consultingwerk, so we are a company that provides like solutions, technology stacks. Obviously, I'm the UK-based section, but we've also got sections in the US, Germany, and Romania. I will go through these relatively quickly because I want to get on to the main stuff. So, as I sort of started off, this presentation is not about educating you about object-oriented design. This is more a case of like how we are using it and how it can help you keep going forward with your development processes and everything else. But the thing, from my own experience, the main consideration which I always take into account is development and the costs of development, primarily the maintenance, because that's where most of the money is spent when we're producing software. And one of the things that I really do come across, and there is someone at the back, I'm not going to say his name. Yeah, he's still over there. Oh, right. The expression I hear every single day, because I do head up a lot of sort of developers from different countries, is they always say to me, well, if it's not broken, why should I fix it? And basically, oh, it's too complex, I'll just add a bit more code to another method. Sorry, for me, as a sort of like an architect, that's just unacceptable. I mean, let's face it, if we have a method which is, I don't know, 50, 60 lines of code, there is large debates on how large a method should be. But if it gets to the point where it's doing more than one thing, it's no longer a proper object-oriented method. You need to seriously look at what you've got in there. I mean, a lot of people will argue with that, but that's my own personal opinion on that one. And for maintenance, it's a lot cheaper to look at simpler code. So basically, those three questions on there, I've deliberately kept this slide on there because it seems strange, but yeah, we deal with it every single day. We do develop object-oriented, even though we may not think so. Personally, OpenEdge is not a true object-oriented language, but it has the class concepts, inheritance, polymorphism, so it's still there. But we can start off thinking, yep, I've got a nice little small package, it's object-oriented. 6 months later, you've put on some enhancements, customer requests, and it can start to look something different than object-oriented. That's one of the issues I see a lot when I'm sort of going onto customer sites. And as I sort of stated there, I mean, whether you're using the term structured or object-oriented, what starts off nicely, it can be deceiving. It cannot necessarily be object-oriented by the time you're finished and released it to a customer. It could be just a conglomerate of objects which don't necessarily perform single responsibility code for doing something I'm responsible for. I will delve into other objects just to do something else. So like a chain reaction kind of thing. But I'm sure every single one of us have come across this with dependency management, especially from legacy systems. I mean, we've all seen code that's, how can we say, a bit of a mess. And we look at it and we just want to cry when we say, I've got to modernize this. No, I'll go on vacation for the next 10 years. It's sometimes easier. I'm hoping that we're all familiar with the solid principles. I mean, I think from my own experience, the main one that we probably use out of all of these 5 is the first one, single responsibility. I mean, by far, that is the one that I come across and I do myself. And at the end of the day, when you're trying to maintain the code, it's much easier when you keep into the single responsibility aspects. I did consider taking this part out this morning, but I thought I'd keep it in there because this is controversial when we say design patterns, even though we do use it every single day. Even if we say, oh, I don't use design patterns, but you do. Because you're going to construct a class or methods within a class, and they conform to a certain pattern. So it could be a singleton class, it could be a factory class. They are design patterns. Even though we may not necessarily be aware of it, we do use it every single day. And some people turn and say, well, I don't know what a pattern is. Look at your own code. You do it every single day. So basically, there's a couple of short notes on there, so what a pattern's there for. It's basically describing what you're trying to achieve. Now, you're going from like point A to point B, so you do need a pattern to sort of get to, or to go through that particular journey. And when you take a look at your structure of classes, that's an architecture pattern. I mean, do you have a domain A, a domain B, a domain C? So you could have a domain which deals with customers, domain C which deals with dispatching. That's a pattern, but that's a pattern on a higher level. That's like an architectural pattern. I'll quickly skip over this one because I've already sort of explained that part there. Now, this is where I believe you all probably go, oh yeah, I'm familiar with this. This is what we call creation. I had to look up on this one initially because I didn't realize they were called creational patterns myself. But there's the main one, the singleton, but also the abstract factory. And I'm sure we've all done this at some point, a prototype. You put a small prototype together to prove the concept of what you're trying to achieve. And then we have the adapters, facades, but primarily the one I think most of us will use on this one is the composite pattern. And the last block is the behavioral. Especially on the state, we'll potentially could have a class which deals with a state, where what I mean by a state is you're changing something, like you're updating a record, you're taking a field from, say, well, if we pick a date, well, I need to change the date from yesterday to today. That's a state change. So primarily try and keep that into a particular state class. Not always easy, but if you can, it makes this sort of maintenance at the end of the day much easier to keep going forward. Now, the criticism of patterns, as I sort of said, the two main criticisms there is inefficient and also it's unjustified. I mean, one of the expressions I heard from a German colleague, I'm not going to say English, but he was a German colleague, he said, if I've got a hammer, I'm just going to treat everything with that hammer. I don't care about patterns. We had a long discussion about that particular point, but that was, in my terminology, quite narrow-minded. That was quite a large, profitable company, but the forward thinking was pretty much non-existent, and that's where I picked that expression from. I'm hoping this part is not going to send you all to sleep, because this is something that we do every single day, refactoring of code. Whether we start off with something that's quite small, we'll look at it and we go, okay, I don't quite understand this code, so I maybe need to refactor some parts. But as it sort of says there, it's a systematic process of always improving code. I mean, the sort of like ambition goal, if you like, is to always leave your code better than what it was when you first picked it up. And obviously also to eradicate technical debt, because that's where most of the maintenance cost comes into play. I mean, we hear the expression clean code. What is clean code? There is a number of definitions on what defines clean code. For me, the basic premise is I can look at a piece of code, I understand what it's doing. I don't have to read a manual, I don't have to read all of the comments just to try and understand what it's doing. It should be clear enough, I mean, whether by method name or even in just the header section saying this is what this method is attempting to achieve. It could be a basic algorithm or it could be an actual process. And then this is the thing that I pay a lot of attention to myself. You'll know if your code is clean or not if it passes the tests. If it passes 95% of your tests, something is wrong. If it doesn't pass any of them, you're royally, I'll let you use the word off this sort of slide for that particular point. But so, I mean, with sort of technical debt, we all try to write code that's good, or what we believe is good. So we pass it on to the next developer, whether it be in 6 months, 2 years' time. They can pick it up and carry on with that code and keep it going forward. But from a lot of the stuff that I've seen, I mean, I've been there myself, and I'm sure we still do, the main contributors to technical debt is business pressure, lack of understanding of what's actually required. That is one of the biggest issues that I've seen. I still get it myself, where a business analyst is trying to say, I require this particular part of the system, it's an enhancement from a customer or something else, but don't fully understand the full requirements of what is required. You can develop something, you go, oh, yep, this is really nice, you give it to the customer, they just go, what is it? It doesn't do anything. It's not what I wanted. Some of the other points here is really sort of pertinent to the modern age, is the lack of testing. Just a sort of quick question. I mean, how many of you guys will write a piece of code and test it? Honestly, yeah, let's be honest with ourselves. So not too many hands there. I've done it myself. I've written a piece of code. I go, yeah, I know that works. I'm not going to test it. Don't need to. That's only 80% of the job. If I don't test it knowing and proving that it does actually do what it's supposed to do, then I'm failing, basically. But one of the other things there is, depending on your team sizes, I'm sure we've all seen it, especially when you've got cross-country teams, the lack of communication. You could have one developer in, say, area A, another developer in area B. They're working on similar things. They don't know it. You get duplicate code, and they're getting different results on what they're producing. Again, this is sort of similar to what I sort of said, but it's the last 2 points which I really want to sort of emphasize on. It's the lack of compliance, i.e. you're not following your, shall we say, company's guidelines, whether it be variable names or method names, and as much as I hate to say it, it's incompetence. We are all incompetent to a certain degree because we'll have our own thoughts thinking, oh, I know better, I'll do it this way. To me, that falls into the category of incompetence. So if you're not willing to listen or to improve yourself, you will never create quality code which is going to save money in the long run. Because at the end of the day, that's what we're all employed to do, is to produce code which, maintenance-wise, should be minimal. There'll always be maintenance and enhancements, but we want to keep those costs down. This is my sort of like basic rule, if you like, is when to refactor. First time, you just want to get it done. Second time, you think, I'll just add a bit more code, it's finished. And the third one is, you're looking at it for the first time and saying, what have I done wrong? What do I need to do? That's when you need to start about refactoring. So that's just 3 sort of basic steps. The other thing with refactoring is, if you've been given, I don't know, some new piece of code or an enhancement today, never try to do refactoring at the same time, because from my own experience, you get yourself in a bit of a mess. Try and keep refactoring and new code completely separate if you can. These are the 2 things where I've got a colleague, he will know exactly what I mean by this particular point. When to sort of fix a bug, obviously, if it's broken in the first place, obviously the unit test has failed, so yeah, it's not clean code, so there's something wrong with it. But also doing a code review. I don't know if all of yourselves have this sort of kind of process in place. If you're a developer, you create code. You're not the one that should glance over it on a final review and say, yep, it's doing what it's supposed to be doing, I understand what it's doing. It should be a colleague. That's where, hopefully, the colleague will say, that doesn't quite make sense, or this is not quite right. You can actually make that more efficient by changing something within that particular piece of code. Because at the end of the day, that's what we're all interested in, is the efficiency, but performance as well. And as it says there about how to sort of like get things done correctly. I mean, if you've got a really sloppy piece of code, it's like thinking, oh, how do I refactor it? Do I have enough time? Maybe only refactor certain parts of it. And you say, okay, I will create a ticket. So I'll refactor, or someone else can refactor the other piece of code at a later point in time. So it's always a continuous process, because you could pick up a piece of code, you're not going to make it 100% perfect straight away. Depend on the size of the code, the complexity of the code. So it could be like a several stage process. And sort of mentioned on that point already, don't mix refactoring with direct development of new features, because from my own experience, it becomes a bit of a mind-blowing experience, especially if it's a large process, which is, I don't know, I say estimated too much. I'll come on to the unit test later on. Code smells. I can't remember the name of the software, but obviously you can have software. It says, oh, you got code smells here. It could be variable names, or you've got a return statement which is not required, or you could have a return statement in the middle of your method before it's finishing the execution of the rest of the code. So that's all sort of typical kind of code smells. And the thing I like about this is, well, in English we definitely do this, we say this quite a lot. When we say code smells, it can stink. You could look at your code and say, oh yeah, on paper it looks all good, but if you put it through like a code analysis piece of software, it'll go, oh yeah, you got hair. They could come up with about 50, 60 code smells, which you don't necessarily sort of see yourself. Like I said, there are plenty of software packages out there that you could use to say, yeah, here's some code smells. No, Jill's was from, yeah, he's not here, but he's got a package which picks up on all of the kind of stuff. Well, you have rules on whether you have indentation or the naming conventions, or whether a method name is too long. That all comes down to code smells. Now, this is one of my favorites, bloaters. Do you all understand the term bloater? No? Right, from an English perspective, you'll have a class method. Initially, you've got a method that's, say, single responsible. It's got 15 lines of code. Over time, someone comes to think, oh, I need to add something into this method. So they'll add another 2, 3, 4, 5, 6, 7 lines of code. Another developer comes in, adds a bit more code. It's getting rather large. That's, in the English term, we call it a bloater. So it's getting bigger and bigger and bigger and bigger. So what it was initially intended for is no longer what it's doing. It's become bloated. As I sort of mentioned on there, I mean, you've got a method. Depending on what your rules are, like personally or internally as a company, you could have a strict policy saying methods should never be over a certain number of lines of code. That's sort of a contention across many different companies, but even a class. You could have a class which is responsible for sending things to a printer, but at some point in time, someone says, right, what I'm going to do here, I'm also going to add in information to update records, saying, oh, I was printed on this date, or I was printed on that date, or I'm going to add in some dispatch information. So that class has now become larger than what it was intended to do. So you had a class initially say, right, I'm responsible for sending things to the printer, period, nothing more. But it becomes extended by adding additional information or additional processes, so it becomes bloated. So it's no longer dedicated to what it was initially sort of intended to do. And one of the other ones where I've got long parameter. Are you all familiar with the term serializable objects? Or objects in general? If you have a method that's got, I don't know, say, 4 inputs, 2 outputs, I mean, we're dealing with classes. Why do we need 2 outputs? There's something wrong with that method if it needs to pass back 2 values. We all know we can have a method as a character or as an integer or as a decimal, so use that. If we do need to have more values in there, potentially you could make the method void, but use a parameter object. What I mean by that is you could have an object which has got, say, your 4 input parameters. They could all be characters. You've got another input character or another input which is a decimal, and that could also contain some output values. So because there's no objects you're passing around, you're keeping your code cleaner and it's easy to understand. So you pass the parameter in, you make some changes on it, but because that parameter is passed in from a parent, those changes are still visible to that parent as well. That's the really good aspect of using a parameter object. Again, this is just something that I quickly sort of threw up. Struggled, so I had to use these sort of like typical progress mentality objects, really. If you've got a class that's looking like the first one person, you've got name, office area code, office number, that's a class with too much in it. It's got customer and other information as well. So consider splitting it down to where you've got just a person class and a telephone class. May look trivial and simply thinking, well, that's obvious. But when you're coding, it's not obvious. You just always sometimes sort of narrow-minded, sometimes you just go, I'll add it all into this class because it seems obvious, easier. But that's where sometimes we fail to look at the obvious side and think, oh, I can actually split that out. It's doing too many things. So now if you look at the sort of like right-hand side, yep, person is only responsible for person, like name, address. Telephone number is literally, I'm dealing with numbers of telephones or area codes. And this is another one where you've got common fields and methods. We've got department employee. We've got commonality between the two classes. If we take a look at get name, you can actually split that out. So, okay, we've got party, and I can then branch down into employee and or department, because there are similarities between employee or department, so you then split it down even further. So you're trying to make your classes smaller and specific to what it's actually there for, rather than trying to do multiple things. Now, I've got these on now. I mean, I've got quite a few more slides on refactoring, because that's what I spend most of my time doing these days. What I mean by change preventers is where you keep going into something, you make a change, you go in there 2 months later, you make another change, and it just gets bigger and bigger and bigger, and you're always sort of changing that particular one. That's used for that. I mean, that's not my term. I did actually investigate that one. It's called a divergent change, where you're continually making small changes onto a particular method, class, and you're making changes that might necessarily be related to that particular class or method. And the other one is called shotgun surgery. Where the term comes on for that didn't really sort of make sense to me. But it's where you're making modifications on, it's a small modification, but you're having to make that same modification in multiple areas, because it's like code duplication. So that's what shotgun surgery means. So you're having to make that same change multiple times for no reason, really. Now, this one is really controversial from my own experience. I mean, it's called dispensables. This is where we're talking, okay, yeah, like I say, it's controversial. You add things into your code which is not necessary. And that'll become clear in a second on this first one. Comments. It was one of my pet hates is when I open up a method or a class and I see more comments than I see code. That really does frustrate me, to be quite honest. And it's not necessary. I mean, a simple solution on that is with OpenEdge, you create a brand new method, you get a header block. If you need to state something, there's a note section, add some notes into there. Or alternatively, give the method a proper name. So the method literally tells you what that's actually going to be doing. I mean, there may be times where someone is saying, right, I need to put a comment in there so I can explain why this formula is doing what it's doing, or this calculation. By definition for myself, the code should be clear enough so someone in 6 months' time or 2 years' time can look at that piece of code and go, yes, I understand what it's doing. If it's not that clear, then we should be looking and saying, I need to make this simpler. How can I make the code easier to understand? Okay, sometimes it's not possible, then maybe some comment to explain that, but when you see methods from my perspective, when it's got 20 comments in there, that's too much, I think. That's why I said it's controversial. Some people say, nah, I like stuff with comments. Other people say, no, I don't. So it's that one. And this other thing with duplicate code. If you know as a developer, I've seen that code before, consider taking it out. So that way you have that code in one single place, whether it goes into another class or into another method within that class. Just have the code once. You save yourself so much grief. It's just mind-boggling sometimes. But it's all through duplicate code in, you could have code which may not look duplicated, but it's doing the same thing. That's harder to spot, but again, if you do notice it, take it out, put it into its own dedicated method, so it's doing just its thing. And the last point on there is dead code. The number of times, this also comes under another point that we were talking about earlier on. You could have a method with variable definitions. They're not even referenced anymore. Why have them there? Remove them. That's what I mean by dead code, but it could be other things rather than just variable names. That also applies to where code has become bloated, where people have just added things and then just don't clean it up. So that it's all part of the sort of clean code aspect as well. This one applies to a lot of stuff that I've seen, and also stuff that I still develop today, is couplers. What I mean by that is you got feature envy. A method acts as the data of another object more than its own data. So my sort of question there would be, why does that class exist? If you happen to rely on another class or two other classes just to do something, there's something wrong with that particular class. Yeah, there are instances where it does need to act something like, so we've got a customer, he needs to access some order information. Yeah, he's accessing that information. But it's when it's getting his own details from that class, then that's feature envy, because then the segregation has not been done properly. Then you've got inappropriate intimacy, what I sort of called it, is when you're accessing internal fields and methods of another class when they should be in its own class. That's where segregation has gone too far. That's what I mean by that particular one. Then we have message chains. This is one of my pet hates. We have a class that calls from A to B to C to D to T to E to F, and it doesn't know where to stop, because the whole design of that particular process was not, shall we say, well conceived. So that's what I mean. And then you have like what I call like middleman. The middleman I've sort of like considered to be sort of like delegation classes, like delegates. If he's saying, well, I'm being called into from an external source, I'm going to delegate process to here, to here, to here, and to here. Why is he there for? If he's not doing any processing himself, to me that's a little senseless to have that class in question. If it needs to do some processing, like some validation or some pre-checking, then yes, that does make sense. But if he's doing nothing and just doing calling to other stuff, then it seems a bit inappropriate to have that class there. I mean, there can be some cases where it may be necessary, but I would always ask the question, why? Again, I've got a couple of little samples on how things can be split up a little bit better. On the left-hand side, you see where it's client class, goes into person, department. That can be broken out, because then the department can still interact with person, but they can still be accessed from the top class to client class. What are we doing on time? Oops. Right, so unit test. I've kept this one short, because I'm hoping we all do unit testing. So, basically, what is the purpose of a unit test? The whole purpose of a unit test is to test the code that we've just written, or test code that's been written by other people. And the thing I state about unit testing, for me, a unit test is to try to break your code. We are not interested in the happy case. Yes, the happy case say, yeah, I can put it through nicely, but the whole premise of a unit test is to try and break code, to see if there's problems with your code. Too many times I've seen and heard, oh, no, my code is working, I've got a unit test for it, it's all good. I could probably go in there and say, right, I can write a unit test to break it within 10 seconds. That's the whole idea for me of a unit test, is to try and break your code. So that way when we actually publish our code, we can have the sort of like faith and security. It's going to do what the customer wanted, which is the key element on anything that we do, because at the end of the day, customer pays our bills or our salaries. And the other thing with a unit test, there's two parts. A unit test is testing a single piece of responsibility. That's what the term unit test is coming from. If it's testing more than something which is multiple responsible, then it's an integration test. So if we're testing a process, that's an integration test. If we're testing A plus or 1 plus 2, that's a unit test. So many people get that wrong in that aspect. But as I sort of pointed there, regardless of how we use it, we want to be able to test our code, because we want to make sure that the path going through that code is doing what it's supposed to do, and the end result is what we're expecting and should come back to how it should sort of be, really. But the other thing with unit testing, again, this is from experience and what I've seen, especially over the last 4 years, is performance. So we're doing good on time, because I'll show you some of the code examples in a second. One of the things that really, really does get ignored, and I mean really does get ignored, when people are writing code, they're writing a unit test to test a code, very little effort is put to the performance of that code. Seriously, I really do mean that. I mean, there's a real-world example. I'm not going to give any sort of names, but there was a particular process. Okay, yeah, the level of class that went down to the whole processes. It came back saying this is taking over 20 seconds to process because of the complexity of what it was actually doing. All of the unit tests were working, but the thing is, the developers, when they built the business task to put it all together, didn't check on the performance. I don't know if you run unit tests within OpenEdge Developer Studio itself, but if you do run a unit test, each method that it calls, you'll see like the millisecond timestamp in brackets right next to it. I'm amazed how many people run a unit test, say, oh yeah, I'm happy because it's green. Check the milliseconds on the side of it. If you're testing a class and you see, well, I'm taking 200 milliseconds on this one, 20 milliseconds on this one, just do a rough accumulation of all of those figures. Oh, it's taking 5 seconds. The alarm bells should be ringing saying, this is not good. I mean, where people turn and say everything should come back in less than a second. That's a good point, but depends on what the process is. There are instances where some things can take a little time, but we need to be aware of that and pay real attention to performance. That is one of the key areas where I've really seen things fall over. So, get on to the demo now. So, I'm hoping that this part will be understandable because it's obviously in Developer Studio, but I'll give you some, well, I'll try and explain some of the issues there. Is everyone okay so far? That everything I've said makes sense? And I've seen a couple of heads nodding. I've seen someone do this. Well, I'm like, So I'll stick on this one. Is that legible? Is that clear enough from where you guys? Yeah, good. Right. So, and Arno, don't say nothing on this one. Right. So I'll try and make this a little bit larger. So I've got this particular method. Yeah, I've changed a lot of names, so it doesn't make that much sort of like sense really. But we've got this particular method, which is public, and it's called from a business task, which this business task is called from a front end. It doesn't matter whether it's a GUI front end or a web front end, doesn't matter. We're coming into a business task. All I'm going to say so far, if I minimize this, you can see it's round about 80 lines of code. You think, well, that's not large, nothing untoward really. But when we take a look at this, we've got all of these objects right at the beginning, which I'm going to be using within this one small method. That's a lot of objects. If I then come down, we've got a transactional block around it, which is okay, nothing wrong with that one. Okay, yeah, I'm ensuring that the object or the data set to record that's coming in, I'm making sure that I'm saying that's definitely 100% available. Then I'll use terms of Consultingwerk. We have a concept called dataset models, which that's a completely different workshop process kind of thing. But what I'm doing is I'm retrieving the record from the dataset that's coming in and putting it into a dataset model so I can then process updates on it, do additional reads on that particular data. Then, if you notice, it says, right, I'm now going to do some validation on that particular record. I come down, here it's saying, do I have any questions that I need to throw back to the user? Think, okay, all good so far. Then it says, depending on what the type is, I will then do some more validation. Then I will run the real main process. So I've done validation first before I get to the actual process of doing what needs to be done. Then after that, it says, oh, I'll take that particular record, do all of this, and then I will update a record. And then finally, I've got a catch in there, then I destroy the objects. So just by looking, okay, yeah, that's a very brief sort of description of what it's doing. This is probably going to be a really stupid question, but does that make sense? Or would you say straight away, that's doing too much? It's not that obvious of what this method is intended to do. So the first thing I'm going to sort of emphasize the point on is, okay, if we have a fat client, yeah, you could have a validation class which has got one or multiple messages. You know those messages are going to show, user goes okay, cancel, cancel, the whole process is aborted. If he says okay, it goes down, there's another question, then another question, then another question. If we're dealing with a web client, is that going to work? No. You ask a question, process stops, it goes all the way back up the stack to the user, user goes, okay. It comes all the way back in, oh, yep, oh, this question's been answered, oh, there's another question, stop, go all the way back up. Do you think that's efficient? Thank you. So, when I picked up this particular piece of code, I thought, this is really bad, because obviously we're dealing with web, not fat client. There is a big difference. And you would be amazed how many developers don't pay attention to that particular button. Just go, I need to add another message. Doesn't matter. I'll just put it in there. But as a user, you would get very frustrated. Just on this particular one, I know from my own experience, this particular validation class was asking 6 questions. Now, that's 200 milliseconds each time it was going in, instantiate the class, go all the way through the code, checking this condition, that condition, ask a question. So 200 milliseconds each time, that's, 1.5 seconds wasted. Sorry, I'm a user, I'm not going to be very happy with that one. So when I looked at this, the first thing I thought, we need to make this more efficient. So yes, I still need to do the validation, but I will not call the main validation class, because you've got all of these different methods that it's calling and everything else. I'll strip out all these messages, and I'll build them all up in one hit, all of the questions, then I'll throw all the questions back to the user. So he can go, yes, yes, no, whatever. But when all the questions have been answered, it then comes back in. It can then do the proper validation, the proper processing. So immediately, I went from a second and a half literally down to about 100 milliseconds, just on that one simple process. That was something that was picked up initially by unit testing. It wasn't picked up by the customer, it was picked up by unit testing when I was thinking, man, there's something wrong here. But that's a simple little thing, but that's what I would consider obvious, but it's not obvious to a lot of people when they're putting code together, because it could be pressure, or I need this done by the end of the week, depending on what your sprint limits are. So now that you've seen that particular one, what I'll do now, I'll drag this one across. If I go up to the top, so this is the same business task, but stripped, a little sort of like stripped out. So if you notice at the top, I've only got one object now, rather than all of this. Okay, I'm not necessarily preaching or trying to educate you how to code, but this is like a practice kind of thing, or a demo saying, this is how you can look at things and go, I don't really see anything, but this is how you really should be looking, how can I break it down into smaller components, if you like. So this part is still the same, because obviously I need to put the record coming in from the outside into a proper record structure so I can manipulate that data later on. And then, if you notice here, the difference, you don't see that here. So that's where I've literally stripped out all of the messaging, put it into a separate, well, I'll go to that method in a minute, that's an internal method in this class, but if I've stripped everything out and put all the message building first, then I'll throw it all back to the user. This is just sort of like checking, saying, right, do I have all the questions in there, or do I have questions, have they been answered or validated already? Then I'll continue. And if you notice, I've also added to this, that's where I was talking about parameter object. This is a parameter object where I could manipulate. Because it's an object, I could add another field on there saying, have I been pre-validated already? As soon as I come into this method, I get all the messages, then I set this to true. So I don't do that pre-validation again. So that saves time, and to me just makes a little bit more sort of sense. And again, if I scroll down a little bit more, you notice all I've got is method calls. So it's been stripped out. So by definition, I would say in 6 months' time, another developer could take a look at that and go, yep, I can pretty much understand what it's doing. It's much easier to read, rather than seeing a big block saying, right, or if this condition, update this record, save it, go into another condition, update the record again, do something else. Now, where I said about this pre-validate. Yes, that's a brand new class, and if you notice, that is very small. It's what? 9 lines of code. It's much smaller, much easier to read. If I need to write a unit test for that method, it's so much easier. Now, if you think I'm writing a unit test for the piece of code on the left-hand side, it just blew my mind. I thought, I'm not going to waste my time and effort to try and create all of the mock data that I would need just to sort of like process all of that processing. It was just a nightmare. Really was a nightmare. Now, whereas this one here, I know exactly what this is doing. This is a pre-validation. I know how to test that very easily. And this method is so much easier and smaller to keep and maintain. But you notice there, I've deliberately marked it as protected, not private. So this is a general question. Why do you think I've done that as protected and not private? Yeah, you can keep quiet. Yes. Now, the thing is, if I write a unit test which says, right, inherit blah, 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 BT, so I can test the methods in there, if it's private, I can't test it. It's as simple as that. The reason I marked it as protected, so I know I can deliberately test it. Anything you do, if you mark it as private, you can't test it. So that's just something which I thought I'd sort of quickly highlight. So again, that's something that can be easily overseen. But you'd be amazed how many times I see a class and every single method is public. I'm like, so again, if I scroll down, you see all the other methods. See, there's a common factor there. They're all smaller. If they needed an object, straight away I stripped it out. I define the object, I use it, I destroy it. 9 lines of code, all very simple. And I've got someone sitting over there thinking, well, I'm going to have to speak to him later. Again, this is where this is actually doing the update. Again, if you notice there, the field it's actually updating is called token. It's nothing special, but I deliberately give the method a specific name. The method, I hope, shows you there what it's actually doing. I'm updating something called a print job record, and I'm updating the token field. So therefore, I call that update print job token. So the method more or less tells you what it's doing. And again, we've got the other validation class. It's all there. It's all pretty straightforward. Where I was talking about the messaging earlier on, it comes into this like pre-validate. Sorry, guys. That's one thing about programming, getting older, get as blind as a bat. So this is the class in question, I think, yep. So if you notice here, if I go right at the top, I'm still inheriting the original validation class. I'm still inheriting it. I've only got that one public method, which is the one I'm calling into on this particular class, which is doing all my pre-validation. Now, all of the other methods, they're all protected and overridden. The reason I'm doing that is these are all the methods where the messages were coming from. The reason I've done it this way, so I can override it, so I can strip out, pardon the expression now, strip out the crap that I don't need. It's like, oh, if a blah, blah, blah. I don't care. I just want to get to the point where I need a message. So I've stripped out all the other stuff. That's the reason why I've overridden the methods. But you notice there, most of the messages, I'm not going to say they're hard-coded, but they're half hard-coded. So it depends on like constant class enumerators. That's where it getting a lot of information from. But the way it's built is sort of half hard-coded with like a GUI value in there. But if you notice, I don't have it. It's just calling into another class. What I've done here, I created a class called this, validation messages. That's what I mean by half hard-coded. It's got, I'm using the buffer that I'm passing into, but that's using like a hard-coded GUID. So it never changes. It's static for that particular message. The difference here is now I have this additional class. I've also got the interface for it, which means I can then use it as a factory later on if it needs to get expanded and be used elsewhere. So that's the reason why I have the interface for it as well. But the originating, the master class, if we like, if I go back to this new class, where I inherit this one, this class now, all those messages that you see in this class have also been removed. So both those two classes, the new class I had created plus the original class, they both now inherit, or use, if you like, this class called validation messages. So all of this code is in a single place. It can be like inherited or used from other areas now. So again, for me, I'm breaking my code down. I'm following the object-oriented principle, saying, right, I've got a class, I've got a task, it's doing too much. I take this out, I put it into its own dedicated class. Okay, I mean, maybe a class called validation messages isn't the best name, but I'd done that last evening. So you didn't hear me say that. But it's a simple way of looking at things, thinking, right, how can I make the code better? How can I make it more efficient? Yes, it may not necessarily always be obvious, but this is just one small step to how you can actually break your code down. You've got much smaller classes, and they can be used elsewhere. You're removing duplication. Yes, you're increasing your number of classes in your application, but what's the choice? Do you have 1,000 classes, or do you have 100 classes which are doing 100 different things? I know what I would go for. So again, with this particular class, if you look at the size of the methods, They're all singular, doing one thing only. Now for unit testing, okay, I mean I haven't written a unit test for that, but I could probably write the unit test for this whole class in less than an hour. I mean, for each method, you got 2 unit tests. Pass me back the record, or the message, and pass me back nothing, null. Because that's what we're interested in. That's all that method can do. It can either pass you something, or it will pass you nothing. There is no in between. It's no, this one, I hate the expression, but that one is literally black and white. There's no grey area, it's dumb. I'm single responsible, I can only do one thing. I can pass you something, or I pass you nothing. That's how you can make your life much easier, by just doing that sort of simple kind of thing. Now, based on, oops, so last one, I will go on to, because I'm running out of time, I could give you a whole workshop for a whole week on this kind of stuff, trust me. So I've got this one in there, and Arno, keep quiet. I've got this particular method. Yes, it's written in German for the German speakers. Look at the size of that method. It's 106 lines. So straight away, my brain is going, ugh. But then, when I expand it, it's, okay, the instantiation there is pretty small. We're using a factory here on this particular point. Oh, but look, if, blah, 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 if, blah, blah, blah. Oh, this one has got an else. Or I go into the else, if, do something, else, do something else. Else, if, do something else. Shouldn't really be saying this, but that's a live piece of code. That's being utilised and used every single day at the moment. That is extremely inefficient. I know this method, performance-wise, is horrendous. And the reason I've deliberately picked this one up because of the size of it, and you can see it's trying to do multiple different things. It was about 2 months ago, I had 3 developers, and I kid you not, it says, I don't want to touch that. I don't understand it, it's too complex. I put my changes in there, it breaks. That's the kind of thing where, over time, this started off very, very small, but it's just been more stuff added to it, and it's now got to the point where developers are too afraid to go near it. So whereas if we now go back to the stuff that I just sort of demoed here, a developer could go in there in a week's time, would not be afraid to go, oh yeah, I understand this, I can add more stuff to it. That's the kind of thing that we need to be aware of, and that's something I do see on a regular basis, and that's worrying when you see developers come out and say, I don't want to touch that. I don't understand what it's doing. And these are senior developers. They're not juniors. So that was the whole part of the sort of like reason why this is the presentation that I gave, because I'm seeing that more and more and more, and that's just, in this day and age, it's quite worrying. We're all using object-oriented principles, but are we really? We're breaking it too much. Even when you see that method, the long method, it's horrendous. The whole idea of like single responsibility, this one completely destroys that concept, literally destroys it. So, I mean, I know the sort of demo is quite short, and I'd love to go into a lot more detail on other stuff, but that's pretty much the end of the presentation, and I hope it wasn't that boring. So, yeah, excellent. So is any sort of questions? Please keep them to a minimum. I've got a flight in 3 hours, so just to mention that part. But yeah, I'm hoping that was informative and that's given you a bit more insight. Let's say, because all of this stuff is coming from a real world, very large project. And I used to have black hair 1 year ago. No, that's not true. But yeah, I'm hoping that was informative, and so, yeah. Oh.